Welcome to the latest episode of the MFG Radio Network's Lunch and Learn, as we highlight some of the latest advances in manufacturing and design, gain insights about the newest products and technologies to move your manufacturing ahead of the competition. We'd all like to welcome you now to our next Lunch and Learn here at GIE Media. I once again am Jake Kaufman, an associate editor for the manufacturing group at GIE. We're now joined by ZEISS. Now, ZEISS is an internationally leading technology enterprise operating in the optics and optoelectronics industries in four key segments: industrial quality and research, medical technology, consumer markets, and semiconductor manufacturing technology. ZEISS develops, produces, and distributes highly innovative solutions for industrial metrology and quality assurance, microscopy solutions for the life sciences and materials research, as well as medical technology solutions for the diagnostics and treatment of ophthalmology and microsurgery. Now, today's presenter is Randall Joyner. Randy has worked as a senior applications engineer for ZEISS Industrial Quality Solutions for 3 years and has more than 40 years of metrology experience in the aircraft industry, specializing in CMM programming, structured light, and advanced manufacturing. He has collaborated on 10 advanced metrology development patents, and today's presentation is called High-Speed Measuring on Aerospace Parts on the Shop Floor. So thanks for joining us, Randy. The floor is yours.
So again, like he said, I have a lot of background in aerospace. I worked for 42 years at a major aerospace manufacturer. My whole career was in quality assurance and advanced metrology. I started working in 1978, programming CMMs in 1980 to 1984 timeframe. 2004 timeframe, I moved to an advanced metrology group, started working with structured light in more advanced measurement systems, and here I am today. It's nice of you all to be here. So one of the things I want to talk about is the current trends in manufacturing. We need to be more resource efficient, have more flexibility, more transparency, and again, new processes. So, they want them to be faster, want them to be very accurate, safe, and flexible. So one of the things I'd like to show at this point is an example from Starog International on manufacturing blades today and how fast they can be manufactured. So in this case, they did a roughing operation, and now they're going to do some probing on the part to find out where the surface currently is. And then in a moment, it'll switch over to doing the finishing. Oh no, that is the finishing, sorry. Here we go. So you can see how fast they can manufacture these blades. So ZEISS decided to look into developing a faster, very accurate way of measuring these parts. So, we looked at, for shop floor, we want to avoid parts being sent to rooms for machines in a controlled environment because you take the parts out of the process. Sometimes these rooms have long queues of parts. You may or may not get any machine feedback for, adjusting your processes on the shop floor. Sometimes there's small air-conditioned rooms on the shop floor, which are painful because you have to have safety interlocks on the doors, to load and unload. Some areas around the machine are blocked, so it makes it, again, hard for loading parts. Feedback to the machine process is very limited. But in all of this, there's still places for high accuracy measurements where the equipment needs to be in the controlled environment. So I'm not saying there isn't a place for those things. It's just not the most efficient method for measuring parts in today's environment with the speeds required. So one of our shop floor machines called a Duramax, it's not as high speed as the newer machine, but it can be definitely integrated out on the shop floor. We have very good support for data management, um, intelligent services, Industry 4.0 support. We have automated loading, unloading fixtures and robots. I was at a facility not too long ago where they have a number of these machines integrated right on the shop floor. They're right inside the machining centers. So, for example, if somebody needed to service the machine, they'd have to get their lockout tag out, open the cage, lock out the power so nobody could go in. So yes, just as you see the machine on the screen there, it's on the shop floor. It doesn't care about the environment. Temperature range for these machines, for this machine is 15 degrees centigrade to 40 degrees centigrade. It has an integrated dampening system, so vibration. And this is a very small footprint. It's roughly a 0.5 meter cubed measuring volume. The next machine is the Prismo Fortis. Now, we have a number of the Prismo Fortis machines that can go directly on the shop floor, but what I'm talking about today is one that we built specifically. We're calling it Prismo Fortis for Aero. It has a specially designed controller so it can run much faster. All of our this particular machine has an integrated rotary table. We support all sorts of sensors, tactile, optical, surface finish. I'll go into it a little bit more. And the same software on any one of these machines for any one of our measurement systems is the same software. So whether it's optical or tactile, all the software is the same. It's our ZEISS Calypso software. So this is an example of the new Prismo for Aero measuring of blisk. Now, typically a lot of people want to run older, passive style sensor, and it takes a long time for measurement. As you can see, now that we've optimized this machine for measuring these parts on the shop floor with 4-axis scanning, we're roughly 12 seconds in airfoil section. We'll be measuring a number of airfoil sections coming on this blisk. And then the other thing we offer is an integrated airfoil analysis package called Comb Blade, which can be automatically run the data as soon as it's processed off the machine. So here again, we're measuring up the whole airfoil, staying in contact for the whole length of time, which tends to save a little bit of time. And as you can see, we're going around the edges without a problem. And that's the end of that measurement. So literally we measured that whole airfoil in just a few minutes. We have, with this new machine, we can save up to 70% of time on measurement of these parts. We have the ZEISS rotary table. With the 3D conic, we can actually calibrate that rotary table on the fly in any program that you have access to the triple conic on the bottom there. It takes roughly 27 seconds to calibrate the rotary table. So, if somebody wants to run their calibration on every part, it's only costs 30 seconds. If they want to run it once a shift or whatever they want in their process, it can be done. The other sensor I want to talk about is our surface finish sensor called the Rotos. That's fully programmable. That adds another 3 axes to our 4-axis scanning machine, so we can orient and measure surface finish. We have multiple styles of probes, and these surface finish measurements are integrated right in the same programming environment. So once we switch to that sensor, we're still running the same CMM program that does all the dimensional checks. So there's no stopping in the middle of things, or to take it off and put it into another operation where they check the surface finish. So this is a screenshot of our Calypso software. We use a CAD-based system, but we don't have to have the CAD, but the CAD makes it a lot simpler. In this case, I'm showing a screen where we say, okay, for these 3 features, the airfoil sections, we want to use the vast rotary table mode, which is the fast mode, which, I've been programming up to 120 millimeters a second on section scanning. It's interactive. We offer MBD feature generation. So if you have model-based definition CAD files, we can read it in and generate programs for measuring parts. If you just have the CAD, you can actually go in and, for example, cut airfoil sections, or if there's features such as holes or planes, you can just select them and it'll generate an inspection path on that feature. Once your features are done and your basic starting alignment is done to know where the CAD is on the machine, then we can set up what is known as a clearance envelope around that CAD, and it will never violate that clearance zone as it's moving from feature to feature to measure things. The other thing we have is a method for optimizing measurement paths. So if you went in and programmed a bunch of features on one side, then went to the other, then went back, it would actually be able to know how to best optimize the machine path for measuring these features. So this is a picture of our ZEISS PyWeb software, showing a trend line of reporting airfoil dimensions. In this case, we did a reproducibility study on 20 measurements of a single part. One of the nice options that we have for using the PyWeb is we actually have a method to where we can generate inspection plans based on your statistical results. So for example, if you say you want to measure anything below a 1.6 CPK, it'll only flag those options and it'll give you a measurement plan for measuring only those features. And then what we recommend is every 5 to 10 parts, you do a full 100% inspection. But if you do a reduced inspection, the software doesn't care because of that clearance envelope that I was talking about. So, we can, bypass features without any, specialized program to get around the part. So one of the things I want to talk about now is active scanning. So, and I can back up just for 1 minute here. So the vast head on the machine is a, where's my mind? Sorry, an active sensor. So what that means is it's like having an individual CMM at the end of the quill of your machine where you mount your probes for the part. A lot of sensors like the older touch sensors or scanning sensors, or even some of the current ones being used by our competitors, they're very passive in nature, which means if you're going to measure something, if it's not where it expects to be, it'll cause an error. So in this case, you can see this measuring an airfoil section. This is, the first airfoil, but if you watch the not the next airfoil, but the second one after it to the right, you can see it has a bent tip. One of the issues with passive sensors is if your part's not where you want it to be, or if there's some, dirt on the surface that may drag the probe wrong, it'll actually error out on the program. Whereas our sensor will just run over these things and continue running the part. So what you would do is, if you had an error or deviation, like for example that bent tip, you'd be watching for the inspection report for bad features, rather than and then you could go back and look at it and say, oh, this is a bent part. I was at a facility when I was doing this video, and the person there said, oh, you got a bent airfoil there, you want something to straighten it? I said, no, we'll just let it run. And as you can see here in just a minute, the probe actually starts hitting the shaft of the probe rather than the sphere. And it'll go up and over and around without stopping the machine from running. Again, that's one of those things. If the probe's not working well, the passive sensor will just stop working. So, and as you can see in just, I think it was a minute per airfoil, we were measuring 7 sections. So, very fast machine. It was under 10 seconds a section. So I hate to say I'm done so fast, but that's what I have together for Shopfloor high-speed measurements.
Awesome. Well, thank you, Randy. So with that, we do have time for some questions. So we'll go out to the audience. They want to know, what are the different size options of the new Prismo or Prismo CMM?
We have a number of different sizes for the Prismo CMM, but the Prismo for Aero with the high-speed option comes in one size, and that's the 7-10-7. So that's 700 millimeters by 1 meter by 700 millimeter measuring volume.
Okay. And then if people wanted to see these in action, where could they possibly get demos?
So right now we're having one of these machines installed in our Wixom, Michigan facility. We have a brand new state-of-the-art demo center there where we can demonstrate all the new equipment. And I believe within the next 1 or 2 weeks, the machine will be installed there and ready for presentations. Other than that, up to this point, we've had to go to Germany for demonstrations. So awesome. It is that new to our system.
Yeah. So. Now, obviously, you said that this is stuff for aerospace parts on the shop floor. Is this kind of a universal thing, though? Could it be used for other industries?
It's a coordinate measuring machine. We call it Prismo for Aero because when we, developed the machine, we were concentrating on, the market where people are making airfoils. But I can say measuring round features, for example, a snap diameter on a disc that's, 24 inches in diameter, it can measure that in, say, 27 seconds, where original method was, I believe, 1.5 minutes, and it reproduced within 10 microns, the diameter and location at the high speed.
Great. Thank you, Randy. We also have one more. So is aerospace manufacturing a separate discipline to aerospace engineering?
So in general, aerospace is aerospace. Manufacturing, you're making the parts. Engineering, you're designing the parts. In design tests, there's a lot of different engineering fields, different things like fluid dynamics for, how do things work? How does an airfoil, flow air and direct it or get power from it? So it's a very interesting field, the engineering versus manufacturing, because a lot of times manufacturing takes what's been designed and already analyzed by the engineers to make it an actual part that you're going to start putting into an aircraft.
Awesome. Well, that I think just about wraps up the Q&A here, Randy. So thank you so much for the presentation. I know I would definitely like to get up to Wixom and see some of this stuff in action. So thank you to you, and also thank you to ZEISS for today's Lunch and Learn presentation.
Thank you, and thank everybody for joining.
You can find more Lunch and Learns, plus the MFG Radio Network's other podcasts on Apple Music, Spotify, Google Podcast, or on our websites at todaysmedicaldevelopments.com, aerospace manufacturing and design.com, and evdesignandmanufacturing.com.